As a reminder, we'll have a quiz on Wednesday. It's very short. Essentially, there's an acronym you have to have learned to do the rest of the chapter. It's called Sohcahtoa. Each letter represents something. You'll use it in my class, use it in Algebra 2, use it beyond, whatever. But in order for you to do Friday's quiz well, you would have had to have already memorized it. So I'm asking for you to memorize it by Wednesday so you could be prepared for the rest of the things that we learn. Okay? And then Friday's like a regular math quiz. The one on Wednesday is super short. Anyways, we're going to do 9.1 notes. There is an assignment on big ideas. So after bingo, we'll start that and go from there. I'll also show you your tests today from Wednesday. All right, so on the back of your notes, there are 3 reasons to use the Pythagorean Theorem. We're going to list them on our notes. So go and write down. There are 3 reasons to use the Pythagorean Theorem. Three reasons to use the Pythagorean Theorem. The first one is the one you're going to use the most. What kind of triangle can we use the Pythagorean Theorem in? A right triangle. It doesn't work in any other triangle. So it's to find the third side in a right triangle. That's the number 1 reason. It's the one you're going to use probably 8 out of 10 times. So find a third side of a right triangle. All right, because you would know 2 sides and find the third. All right, and then the second reason you use it is to decide if a triangle is a right triangle. So your second reason is to decide if a triangle is a right triangle. If it is a right triangle, then what do we know about a squared plus b squared? It will equal c squared. So you're looking for the left to equal the right. If it does, then it is a right triangle. Okay? You always plug in the biggest side in for c. Okay? The third way we use the Pythagorean Theorem is to decide if it is acute, right, or obtuse. So you can use the Pythagorean Theorem to decide if your right triangle, or if your triangle is acute, right, or obtuse. And you do a squared plus b squared, and you compare it to c squared. So if c squared, which is the hypotenuse squared, if c squared is smaller than a squared plus b squared, what kind of triangle will that be? Acute. And then the opposite, if the hypotenuse squared is larger, that means it is obtuse, an obtuse triangle. So we're going to practice all 3 of these on the last page of the notes and then finish our game. So go ahead and go to the 3rd page there. We're going to start with find the value of x, then tell whether the lengths form a Pythagorean triple. A Pythagorean triple, bless you. They're all whole numbers that satisfy a squared plus b squared equals c squared. So not all 3 whole numbers in the world make a Pythagorean triple, but as long as they make a squared plus b squared equals c squared and they're whole, then they are a Pythagorean triple. So we're going to use the Pythagorean Theorem. A squared plus b squared equals c squared. Which of these is c? 25. It's across from that right angle. Does it matter which one I call a and b? It does not. So 15 squared plus x squared equals 25 squared. 15 squared is 225. You're going to see that number a lot, just in general. And then 25 squared is 625. So you subtract 225 to get x squared by itself. So x squared equals 400. And then take this square root. And that means our last side is 20. Is this a Pythagorean triple? Yes. It's once again the most common Pythagorean triple. What did I say was the most common? 3, 4, 5. And all three of these, if you reduce them down, they're all divisible by 5. So 15 divided by 5 is 3. 25 divided by 5 is 5. Anyways. All right, the next one, it says the flagpole shown is supported by 2 support wires. Use the Pythagorean theorem to approximate the length of each wire. So what do we notice about these 2 triangles? They're congruent. It's the same triangle. So you can just pick one of the right triangles and go from there. So I'm going to use the one on the left because why not? And we will still use a squared plus b squared equals c squared. Which of these is going to be c? X. Oops. It's across from that right angle, so that's good. X squared. So that means we have 8.5 squared. What's b going to be? 15.1 squared. You don't want to round in the middle of the problem, so whatever it says, you should just write it down. We're going to get 2 decimal places. What is 8.5 squared? 72.25. Plus 15.1 squared. Correct, 228.01. We're going to add them together. It's 300.26. Equals x squared. And then take the square root. And so that missing side is 17.3. That's what you said. And then you'd say feet. Remember that we were solving for the hypotenuse, so it should be the longest side. It is. It doesn't ask, but is this a Pythagorean triple? No. So from the beginning, they were all decimals. So. All right, so we use it here. There's one example on this paper, and then the other one isn't, but we're going to write it down and do it anyways just for practice. But first, we're going to tell whether this triangle is a right triangle. We do that with the Pythagorean theorem. We want to see if a squared plus b squared equals c squared. Which of these sides is going to be c? 12. It is the longest side. So we're going to plug in 12, which means we're going to have 8 squared and 4 square root of 5 squared. So how do I represent that all of this side is being squared? Parentheses. Good. 8 squared is 64. And then I'm going to go off to the side and do 4 square root of 5 squared. All of it's being squared. What's happening between the 4 and the square root of 5? Being multiplied. So you want to distribute the square to both parts. And then you would have 4 squared, which is 16. And then the square root of 5 squared. 5. Remember, they cancel each other out. And then what is 16 times 5? 80. And we want to see if that equals 12 squared. 12 squared is? Good. What is 64 plus 80? 144. 144 equals 144. So this is a right triangle. This is why it's crucial to make sure you get that number correct, the squaring of the radical and all that stuff. You're going to write down the last question. It's very small on my screen because that's how it would fit. But we're going to verify that 3, 4, 6 form a triangle and then decide if it is acute, right, or obtuse. So we're going to verify. I'll give you a second to write it down. We're going to verify that the lengths form a triangle first and then decide if it is acute, right, or obtuse. We're writing it down. So when we verify, what do we have to do to verify that lengths form a triangle? Add the smaller ones, and they should be greater than the largest one or longest one. So in this case, when we want to verify that 3 plus 4 is greater than 6. So is 3 plus 4 bigger than 6?
Yes.
It is. So it is a triangle. Now we want to figure out what kind by doing a squared plus b squared, and we're going to compare it to c squared. So remember, if c squared is smaller, that means acute. If c squared is larger, that means obtuse. All right, so a and b will be 3 squared, and 4 squared, and compare it to 6 squared. 6 squared is 36. What's 3 squared? 9, and 4 squared? 9 plus 16 is? And we're going to compare it to 36. So again, I always circle so that I remember which one matters. We're looking at 36. What kind of triangle do we have then? Obtuse. So it's obtuse. Because 36 is larger than 25.